So sometimes we're able to assign values to categorical data, and if we can do that in a meaningful way, that enables us to compute the mean and variance and standard deviation. In this example, we have the party for 10 voters. They're either Democrat or not Democrat, so this is a binary variable. For a binary variable, often you can assign values 1 and 0. If we're interested in the proportion of Democrats, we would assign 1 to a Democrat and 0 to not a Democrat, and then the sample mean would actually represent the proportion of Democrats. So that's what I'm going to do here. Anna's the Democrat. I'll assign value 1. Bob and Clyde are not. I assign value 0. Denise, Ellen, and Frank are Democrats. Value of the variable is 1. George and Hillary are not. Value is 0. Isaac and Jill are Democrats. So then the total is going to be 6, and this actually represents the proportion of Democrats. And then we can compute the mean. The mean is the total divided by the number of voters. So it's 6 divided by 10, or 0.6. And this represents the proportion of Democrats. So it does have some meaning. The mean here actually has some meaning here. And this is a special kind of a mean because if the data set has only zeros or ones, then the mean is represented by the symbol p hat. It representing the proportion. P hat stands for proportion from a sample. Once we have the mean, then we can compute the variance. So it's each value of the variable minus the mean. 1 minus 0.6 is 0.4, and then square that. 0.4 squared is 0.16. 0 minus 0.6 is the negative 0.6. Square that. We get 0.36. A negative times a negative is positive, so it comes out positive. So each of these with value 0 are going to be negative 0.6 squared. So these are all the same. Negative 0.6, negative 0.6, 0.36, 0.36. And if the variable is 1, these are all going to be 0.4 squared. So these are all 0.4, and then square it, you get 0.16. Okay, so this middle column should be 0, and then the last column adds up to 2.40, and then if we divide by n minus 1, that gives us the variance. So s squared, or the variance, is the last column total divided by 9, and it comes out to be 0.26, and repeating 6s. So that's the variance. And then the standard deviation will be the square root of the variance. So S for the standard deviation, square root of 0.26, and repeating 6s. And we can do that on the calculator. Second square root and 0.26 and repeating 6s, and equals about 0.516. Okay, so that's the standard deviation. So if you have categorical data, if there is a way to assign numbers to the values of the variable in a meaningful way, then you can compute the mean and variance and standard deviation for that data set. And that concludes this presentation.